And good morning, everybody. We're going to learn something new today in our warm-up. Okay. These are called KenKens. Okay. And they're a little bit like Sudoku, but you got to do some math. You got to do some logic. Okay. You got to know how logic works. Okay. So that's what we're going to learn on this. Should be kind of fun. Go ahead and copy down that first half of the warm-up. Okay, hopefully you had time to finish that. Now let's copy down those two triangles at the bottom. And I want to show you this symbol, right? Now that's not a squiggly line like what I'm estimating. That bottom line is straight, okay? So this weird looking like equal sign, when the top line is squiggly, but the bottom is this is a geometry symbol, and that means similar. Okay, and remember last week when we learned about similar triangles or similar shapes, that means they have the same shape, not necessarily the same size, right? One's bigger than the other. So again, these triangles are similar. That means that this angle down here is the same as this angle. This angle here is a right angle. That angle must be a right angle. And whatever I measure that angle to be, it should be the same as this one. The shape is the exact same. One's bigger than the other. Okay, and that means they're in what we call proportion. Okay, and if they are in proportion, and I have some of the numbers, I can usually find out the missing numbers. So I know that this is 10, this is 24, this is 26. I know this is 15 and this is 39. I don't know what this is, but I have enough information to figure out what it is and prove it. Okay, that's when we write equivalent ratios. And equivalent ratios, remember, is a proportion. Okay, and if I have 3 of the 4 numbers, okay, I can solve and figure out the 4th one. So we're going to have fun with this. We're going to have fun with this. And the rest of the warm-up, good practice, right? Hopefully you have fun with these diamonds. All right? All right. So hopefully you pause that, copy that down, and then you go start trying to solve the entire thing. Okay, I'm going to go ahead and press pause and let you guys continue to try to solve that. Ask your teacher for hints if you get stuck. All right, let's do these diamonds first. Okay, and then we will explain how to do the KenKen, and I'll pause and let you try that. Okay, all right, first off, what two numbers have a product of 40 and a sum of 13? Again, that's two numbers when you multiply, you get 40, and when you add, you get 13. Hopefully you figured out that is a 5 times 8 is 40, and 5 plus 8 is 13, right? 5 and 8 have a product of 40, 5 and 8 have a sum of 13. Okay, learn that language. How about two numbers have a product of 54 and a sum of 15? Hopefully you figured out that's going to be 9 times 6 and 9 plus 6. All right. KenKen. Okay, so this is a 3 by 3 KenKen. That means the only numbers allowed, okay, these are the rules. The only numbers allowed are 1, 2, and 3. Okay, and you can't have more than 1, 1 in a row, or 1, 2 in a row, or 1, 3 in a row. That means these numbers, I have to have a 1, a 2, and a 3 in these numbers somewhere. Okay, same thing with the columns. Okay, I can't have more than 1, 1 in this column. I can't have more than 1, 3 in this column. I can't have more than 1, 2 in this column. I can't have more than 1 in this, right, and so on. And the other thing you have to pay attention is, of this 3 by 3 grid, these two squares are in a rectangle that's bold. So this 3 times, I have to have two numbers that multiply times equal 3. Okay, can I use a 2 as one of those numbers? No, it has to be 1 times 3 or 3 times 1. Now, I don't know if a 1 goes here or a 3 goes here. I don't know if a 1 goes here or a 3 goes here, but a 2 cannot go here. But I have to have a 2 in that first row, so what do you know? Logic leads us to say there must be a 2 in this box, because I can't have a 2 in these boxes. right? Now, how do I get three numbers to equal 8 if all I'm using is 1s and 2s and 3s? Well, the only way to do that is to have 2 3s and 1 2. Can I have a 3 here and a 3 here? No. Can I have a 3 here and a 3 here? No, I can't have 2 3s in the same row. I can't have 2 3s in the same column. So I have to separate those 2 3s. I'm going to have a 3 there. I'm going to have a 3 there, which means this must be what? Right? And again, this is the logic, okay? Now, I think I gave you enough clues that I want you to try to do the others. Now, remember what this is. This equals 1, but I subtracted. Okay, so I got a 2 here. I didn't have this 3 here. I would think, well, that could be 3 minus 2 equals 1, but it could also be 2 minus 1 equals 1. But once I get a number here, I know what that has to be. Okay, I'm going to press pause. I'm going to let you see if you could fill out the rest of the box. And again, when you're done, check and make sure you have a 1, a 2, and a 3 in each row, a 1, a 2, and a 3 in each column, and there's no duplicates. And then go make sure that your box, this rectangle here, is I subtract 2 numbers to get 1. This rectangle here, I multiply 2 numbers to get 3. This shape here, I add 3 numbers to get 8. And this shape here, I subtract to get 1. Okay, press pause. All right, how'd you do? All right, so I know this has to be a 3 and a 1, but I already have a 3 in this column. So the 3 and the 3 and the 1 has to go over here. And the 1 is going to have to go here. And check this out. I have a 1, a 2, and a 3 in the first row. Now this column, I have a 2, a 3, and I don't have a 1. And if I put a 1 there, does it fit? 2 minus 1 equals 1. So I have a subtraction problem equals 1. Now, I have a 1 and a 3 here. What should go here? Well, it should be a 2. Now, does that fit our problem? When I add the numbers to get 8, 3 plus 2 is 6 plus 3 more is 9. Uh-oh, Mr. Daniel made a mistake. Wait, 3 plus 2 is 5 plus 3 is 8. 3 times 2 is 6. Phew. All right, so that works, right? Now, I have a row missing a number and a row missing a number. This has a 1 and a 3 in this row, so that should be a 2. This has a 2 and a 3 in this row, so that should be a... And can I get 1 subtracting using these 2 numbers? Yeah, 2 minus 1 is 1. See how that works? These are kind of fun. I'm going to include these for a while, okay? And if you really like these and you like the challenge, I'm using 3x3s that are kind of basic. They have 4x4s, 5x5s, and they have a much more number. So if there's a 4x4, then you can use 1 through 4 in each row, 1 through 4 in each column. If there's 5x5, 1, 2, 3, 4, 5 in each row, right? And they get bigger and harder. If you like the challenge, step it up. If you're able to complete it, okay. I like something to be a challenge, but not so hard that I can't do it, right? Okay, that's the zone you want to sort of play in life, right? That's the growth mindset zone. Okay, all right. 3 to the third power. 3 times 3 times 3 is not 9. It's 3 times 3 is 9 times 9 times 3 is 27. 4 times 3 times 4 times 4 times 4. Ooh, common mistake, huh? It's not 12. 16 times 4. It's not 16 times 3. So you got 48. That's what you did. 4 times 4 times 4. I get 16 with those 2 4s when I first multiply the 4 times 4, and then 16 times 4 is 64. 5 to the third power is not 15. It's not 75. 5 times 5 times 5, right? 5 times 5 is 25 times 5, not times 3. 25 times 5 is 5 quarters, 125. 6 times 6 times 6 is 36 times 6 is 216. And what's 14 squared to the second power? That's 196. Square roots. What number squared is 49? 7. What number squared is 16? 4. What number squared is 81? And what's the square root of 64? And who chickened out and who rose to the challenge? Okay. Again, multiply fractions is easy. All right. What times what is 9? 3. What times what is 25? 5. Right? So think of 3/5 times 3/5 straight across the top, straight across the bottom. 3/5 to the second power is 9/25, so the square root of 9/25 is 3/5. All right, different ways of doing this. You can use a generic rectangle and do 3 2/5 times 4 2/7. Some people just use the C method and make these fractions. Some say 5 times 3 is 15, plus 2 is 17 fifths. 4 times 7 is 28, plus 2 is 30 sevenths. I'm going to go straight across the top, straight across the bottom. I remember 3 times 17 is 51. So that's 51 and a 0, right? And 5 times 7 is 35. Now I have to divide 35 into 510. Or could I simplify before I start? You guys ever see that? Cross cancel. 5 goes into the bottom here 1 time and goes into 30 6 times. So I could have said 1 times 7 on the bottom and 6 times 17 on top. 6 times 17, I'm just going to tell you real quick, since 3 times 17 is 51, 6 times 17 is twice that. That's going to be 102. Okay, 2 51s. So let's just double check. Use a standard algorithm. All right, 6 times 7 is 42. Carry the 4. 6 times 1 is 6 plus 4. It's 10. Boom. Now, how do I simplify this? Divide the bottom into the top. 7 goes into 102. Okay, now it goes into 10 one time. 1 times 7 is 7. I subtract. Now I bring down the next number. I got 32. How many times 7 go into 32? 4 times, because that's 28. My remainder goes on top, divides on the bottom. 14 and 4 sevenths. And when I estimate that, that sounds about right, right? This is about 3 times about 4. 3 times 4 is 12, but I know it's going to be bigger than that because I rounded that down to 3. I rounded that down to 4, right? So it should be bigger. 14 to 4 sevenths sounds right. All right, subtracting mixed numbers, stack them first, and then get some common denominators. Okay, what's the number that 2 and 7 both go into? Well, 14. Here I did 2 times 7 to 14 to get 14. I got 1 times 7. 7 14ths is the same as a half. Here I did 7 times 2 to get 14. I got 2 times 2 is 4. And now my problem, math joke there, right? Pun intended, is I'm trying to take 7 14ths from 4 14ths. I don't have enough 14ths. So I got to borrow from the, coincidentally, a 14. I borrow 1 whole because I needed some more 14ths. How many can I get? 14. How many did I already have? 4. How many do I have now? 18. So don't just go put a 1 in front of that. Now I have 18 14ths minus 7 14ths is 11 14ths. And 13 minus 4 is 9. Okay, if you got that, pat yourself on the back. I'll wait. Good job. All right. Multiplying, again, a mixed number. Okay. 12 times 3 is 36 plus 1, 37. Thirds. 9 times 3 is 27 plus 4, 31. Ninths. Okay. That's going to be a big number when I go 37 times 31, huh? I know the bottom is 27, but that top, 37 times 31, I'm going to go up here. Use a standard algorithm. 1 times 37 is 37. Put a placeholder. 3 times 7 is 21. Carry the 2. 3 times 3 is 9 plus 2, 11. So 1,147. Yikes. Mr. Daniel, how come you made this so hard? Okay, now I have to divide 27 into 1,147. This is a challenge. Okay, we did not get enough practice in long division when we were in 5th grade. Okay, so we're going to get some practice. Okay, and if you can do this, pat yourself on the back. Now, 27 won't fit into 1. It won't fit into 11. It will fit into 114. How many times? Well, I'm thinking that's about like a quarter, a little bit more. 25, 50, 75, 1. 4 times, right? 4 times 25. And then I go multiply. Now, if you can multiply like this, like I can, great. If not, come over here to the side and figure out what it is. Okay, you might need it again later anyway. 4 times 7 is 28. Here are the 2. 4 times 2 is 8 plus 2, 10. 108. Now I subtract. I get a 6. What do? Write down the next number. How many times is 27 fit into 67? I think it's only going to be 2 times, huh? Okay, and again, come over here and multiply if you need to. Otherwise, I'm pretty good at doubling things. 2 27s is going to be 54. And subtract. Now remember, your remainder goes on top. Divisor goes on the bottom. 42 and 13/27. Good job. All right. Dividing 38.4 divided by 0.3. Okay, now first off, that first number goes inside the box. I'm going to go ahead and write it up here. Now, if you start dividing, I'm going to run away from you. I don't want to be near you when the math police come and get you. You cannot divide with a decimal outside the box. Okay, you got to get rid of it. Now, to get rid of it, you got to move it over 1 scoop. But if I move it over 1 scoop outside, I got to move it over 1 scoop inside. Now look at that problem. You got 4 decimals and 2 scoops. That looks a little confusing. Spend the extra 5 seconds and rewrite your problem. This problem, 3 into 384, is so much simpler and less confusing than that one. Okay? So 3 goes into 3 1 time. 3 goes into 8 2 times. 2 times 3 is 6. Write down the next number. And 3 goes into 24 8 times. So this ends up being 128. Okay? Do not divide with the decimal outside the box. Okay. What do we know? We know 3 of these numbers. We know 2 of these numbers. We're trying to figure out that last number. Okay? So I want to find out what the x is. So I'm going to go ahead and put the x on top here. And what do I want to compare it to? Well, it's your choice. I can do x is to 24 because these are both the heights. I can do x is to 15 because these are both on the big triangle. I can do x is to 39 because these are both on the big triangle. Okay? I'm going to go ahead and do the height to the base of the big one. X is to 15. And do the height to the base of the small one. What's the height of this? What matches up with the x? The 24. What's the base of this? What matches up with the 15? The 10. Okay? Now, I lucked out by doing it that way. Okay? There's other ratios you could have set up, other proportions, but I lucked out, and you're going to see why in a minute. Remember, our first step of solving a proportion is to cross multiply. Okay, x times 10 equals 15 times 24. All right, let's figure out what 15 times 24 is. Now, some of you can do this in your head. 10 times 24 is easy, right? It's 240. Well, 5 times 24 is going to be half of that. Cut something in half easily. So 15 times 24 is 10 times 24 plus half of 10 times 24. You can do that in your head almost, huh? Okay, let's just prove it with the standard algorithm. 5 times 4 is 20. 5 times 2 is 10 plus 2 is 12. Put a placeholder. 1 times 4 is 4. 1 times 2 is 2. Add. What did I get? Okay, so I have x times 10 equals 360. What's x? Well, some of you figured that out in your head already, but let's do the algebra steps. My goal is to isolate the variable, get the x by itself, so I have to get rid of that times 10. You do that with the opposite. What's the opposite of times 10? Hopefully you figured out it's divided by 10. But if I did this to my equation would be out of balance unless, you guys want it? Bracelet request. Do the same thing to the other side. Okay, if I do this side divide by 10, I got to divide this side by 10. Now they cancel out on that side. All that's left is x. And what's 360 divided by 10? Move the decimal one spot that way, divide by 10. Move the decimal two spots that way, divide by 100. Three spots that way, divide by 1,000, right? Kind of cool trick to know. So you should get 36 on that, okay? Okay. Ask me about heights of trees and heights of lampposts, and I will show you how to use math to figure it out. All right. Sorry for the long warm up on a Monday. Have a great day, everybody. Have a great week.